Greetings, everyone. I want to spend just a few moments here talking about the domain, codomain, and range of functions, and kind of relate it to what we do in computer science and how these concepts helps us write better code as computer scientists. So let's take a look at this equation here. So the first one I got set up here, it says that f of x is 2 times x. So the definition of an even number. But we've added some more constraints to it. We've said where x is an element of the positive integers and x is less than 6. So we've got those numbers represented over here on this side, right? This is the numbers that are positive integers less than 6. 1, 2, 3, 4, and 5. That gives us the domain of our function, right? The domain tells us what does our function accept. Our function accepts an x value where x is a positive integer less than 6. So our domain is just this entire side over here. It's a 1, it's a 2, it's a 3, it's a 4, and it's a 5. Our codomain. Our codomain is just anything that this could produce, right? And it looks like it could really produce any fit this description. But I've also got kind of an example listed out over here. So this gives us the 2. 2 times 2 is 4. 2 times 3 is 6. 8. And we just have all the even numbers. And this is really all the even numbers. I didn't really take the time to write them out here for this equation, but the codomain is just all the even numbers. This function produces even numbers. It's the definition of an even number, 2 times another number. Gives us the codomain, all the even numbers. But let's take a look here, because I want to talk about range. Range is going to be an important one. Range is not the codomain, but it's a subset of the codomain. The range is the values that this function actually produces. So if I were to take out my red marker here, and I start drawing the lines where if I plugged in an x of 1, so f of 1 gives me 2 times 1, gives me 2, and I just connected the dots. That 1 in the domain goes to this 2 in the codomain. Do the same thing with this 2. If I plugged in a 2 into this function, I'd end up with 2 times 2 and get 4. I can do that with all of these. Stops at 5, but my codomain, it keeps going. So it doesn't include 12, 14, 16, and all these other values. So our range is just the values that this thing actually produces. So this thing actually produces a 2, and a 4, a 6, an 8, and a 10. But it doesn't keep going. It doesn't keep producing the 12 and the 14. The range is the values this function actually produces. The codomain is the thing it could theoretically produce. This could theoretically produce any even number. Because of the constraints that I've added to my domain, these are the things we will actually possibly get. Talk about is this idea of the most restrictive domain, codomain, and range. So a lot of times as mathematicians and computer scientists, this is what we really care about, right? So just defining a domain, codomain, and range is actually really simple. As mathematicians, all the complex numbers will guarantee to include everything in your main, everything in your codomain, and everything in your range. But that just doesn't really tell us a whole lot. A lot of times I hear so much about what the thing actually, theoretically could be. I care what we use this with, right? Where does this actually legitimately apply? So let's see if we can't do a little bit of detective work and solve this. So for our domain, actually aren't given a lot of constraints on what x can be, right? Only thing we know about x is that x is an integer. And that's pretty much as deep as we can go. There's no other additional constraints limiting what x could be in this situation. So as far as we're concerned, our domain is all the integers. Easy enough. Well, let's talk about our codomain. For our codomain, look at what this function's actually doing. So if we take a look at this function, we'll see that, hey, this is the absolute value of x. So we're ignoring any negative numbers. If x was -3, this would make it +3. +3 plus 2 would give us 5, so there's no way to get a negative number out of this. So that tells us, hey, wait a minute, our codomain isn't really just all of the integers, it's all of the positive integers. Starting at 1, 2, 3, 4, and so on, off to infinity. But now let's look at the range. Let's take just a little bit of a closer peek at what this function is actually doing, right? What does this thing actually really produce? What is the actual value I'm going to this? So I know it's going to be some sort of subset of the codomain, but can we get... Let's take a peek, right? What's the value we can get out of this? Well, we know if we go negative, we get to 3. And if I just put in a 1 here, that's just absolute value of 1 is 1, so 1 plus 2 is 3. But what if x was 0 at this spot? 0 is considered part of an integer. So if I put in a 0, I get the absolute value of 0, which is 0, and I get 0 plus 2. So it looks like I'm including everything in the positive integers plus 1. There's no way to produce a 1 out of this. There's no way to do it. We can only get 2 and above, and that's how we can indicate that using our set symbol from earlier in the semester. The last thing I want to talk about here is just kind of to relate all this back to a computer science context, right? So the idea of actually relating this back to a program. So I've set up a function here in Java, C++, C Sharp, whatever, right? They're all going to kind of look like this. But let's take a look at the breakdown of what this function looks like. So my return type is an integer. It's called my function. It has one parameter, that's a byte called x, and it just returns x modulus 2. So this thing's just spitting out zeros and ones. Pretty much just going to determine if it's an odd number or not. Let's take a look at my domain. So our domain is just what that function can take in. So what can this function take in? Well, it takes in a byte called x. Well, what values can a byte be? Well, it can be all the values from 0 to 255. Easy enough. Well, what about the codomain? Well, the codomain is just everything this thing could theoretically return. Well, that's what's going to be, take a little bit here, 2 to the power 31, or a 32-bit integer. You can see that up here in the return type. But what is the range? This thing's actually returning. Well, if it's modulus 2, the only thing this thing's ever spitting out is zeros and ones. So you could at that point say it's maybe returning a bool if you wanted to, but not to get into the semantics of any particular programming language. Here you can see we have the domain, which is just all the different states of our parameters, the codomain, all the different states of our return type, and the range, which is just the states our return type actually could be. This thing could actually produce a 0 or a 1. So that's kind of how this domain, codomain, and range business all ties back in to computer science. That gives you a little bit of extra understanding about the domain, codomain, and range of functions, and a little bit about why we care about it and why it applies in the context of computer science and software engineering. If you have any questions, please send me an email, and you have a wonderful day.